This is the third in our series addressing measuring student performance. This lesson will focus on using descriptive statistics and will concentrate on reliability, which is the first concept in descriptive statistics. This is the overall outline of basic concepts included in this series of lessons. As you can see, the outline section highlighted in red font and underlined shows us we will focus on reliability. Under reliability, we will cover 1. Reliability definitions, 2. Reliability studies, 3. Factors that influence reliability, 4. Evaluation of reliability, including reliability coefficients, error in measurement, confidence intervals. 5. Understanding and using reliability study results. Number 1. Reliability definitions. Reliability in layman terms. A reliable person can be counted on. A reliable test produces consistent results. A reliable thermometer, instrument of measurement, consistently shows a measurement of a given temperature, boiling, over time. It doesn't tell you a different reading or measurement for the point of boiling. Let's use an analogy to understand the relationship and importance of these two terms, reliability and validity. If you have a babysitter, Judy, that shows up every morning exactly on time, she is consistent and therefore reliable. You can depend upon this babysitter. That is a good thing. But if Judy does a poor job, even though she is reliable, she is not a good babysitter. Let's say you have another babysitter, Marty, that does a wonderful job. She plays with the children, keeps them safe, gets them to bed, cleans up the house before you get home. She is a wonderful babysitter. She is valid for this important job. But if Marty doesn't show up on time, she is unreliable, and therefore she's not a good babysitter. So to have a good babysitter, we need one who is both reliable and valid. The same can be said for a testing instrument. The two important questions are, how do we define reliability in testing instruments? How do we measure reliability in testing instruments? Teachers and educational diagnosticians need to thoroughly understand the answers to these questions. So for now, focus on reliability, and in the next lesson, we will address validity. Here are two more reliability definitions. Here are two more reliability definitions. The extent to which a test is consistent in measuring whatever it does measure. Dependability, stability, trustworthiness, relative freedom from errors of measurement. Reliability is usually expressed by some form of reliability coefficient or by the standard error of measurement derived from it. Reliability studies establish the evidence that a test is reliable. There are three basic procedures for reliability studies that you should know. A. Reliability studies are conducted on large groups of individuals before assessment instruments are published. This is called the norming group. In fact, many publishers now insist upon having 1,000 individuals in the norm group. B. Reliability studies are repeated when the instrument is being revised, usually every 10 years. Why? Because things change in 10 years. Knowledge changes in 10 years. Just think of the telephone you used as a child and the phone you use nowadays. C. Reliability studies are reported in the instrument manual. There are 5 types of reliability studies that test authors use to establish the reliability of their test. Generally speaking, test authors will conduct several of these, but may not use all. For example, inter-rater reliability would not be used on a test that does not involve people rating a student. The different types of reliability studies will be completed sometimes on the whole population taking the test and sometimes on specific groups of the population. Many times one reliability study will be completed on the whole population and then reported by specific groups, such as all kindergartners or all Hispanic students. Here are the first 2 types of reliability studies we will examine: test-retest and alternate form. Read through this slide. As you can see, the procedures for the different reliability studies are different, and that difference yields very important test reliability. Split half and internal consistency reliability studies serve the same purpose, examining the consistency of the actual test items. Read through this slide. Again, the procedures for each are very significant in establishing test reliability. Some tests require professionals to observe and rate a student's behavior or performance. The behaviors have to be defined and described on a scale. The rating system must be clear, and the reliability studies help establish that when 2 people rate a student whom they have observed at the same time, the 2 raters will consistently rate the student at the same level. In the following slide, an example of a rating system for observing caregivers' interaction with preschoolers will help you understand the concept of inter-rater reliability. So if 2 raters observe the same caregiver on the same day and time, if this system is reliable, then both raters should come to very similar ratings of the caregiver. As you can tell, if the rating system only used numbers, the 2 raters may have different conclusions. The same could be said if we only used the rating terms. It is the combination of the numerical ratings, descriptive terms, and definitions of the rating terms that enable inter-rater reliability to be established. There is one more procedure that would make inter-rater reliability stronger. That is, if the 2 raters are trained together. Teachers and educational diagnosticians, as well as principals, need to understand the multitude of factors that can influence test reliability. Why? Because educators create tests and give tests and interpret the results. Here are the 6 important factors that influence test reliability. 1. Test length. 2. Speed. 3. Group homogeneity. 4. Item difficulty. 5. Objectivity. 6. Test-retest interval. And 7. Variation with the testing situation. Think about yourself and testing. You know if a test is too long or too short, your performance might be different. You know that time tests may cause you or your best friend to have great test anxiety. I remember hating the timed multiplication fact tests in elementary school, and they're still using those things. The third factor, group homogeneity, tells us that the test authors should not base their test upon a group that are all white, middle-class urbanites. The test population needs to include different types of people. Item difficulty is extremely important in establishing reliability. That is why some reliability studies are focused just on test items. There should be some hard questions, some easy questions, and many that are in the middle. When it comes to objectivity versus subjectivity, reliability is higher for objective tests. However, with the use of well-designed rubrics and inter-rater training on the use of those rubrics, subjectivity is more controlled. An example is the use of rubrics to evaluate students' writing samples. When it comes to test-retest interval, it is easy to understand that there should be a short time frame in between test-retest reliability studies. Generally speaking, the rule is 1 or 2 weeks in between the 2 administrations of test-retest or alternative forms. Why? If we wait too long, let's say a month, the students have learned new things and changed in that time frame. Therefore, the results of each administration are influenced by the interval. Variation within the testing situation or environment is easily understood. It's the one reason teachers must remove everything from the walls and bulletin boards on state testing day. The evaluation of reliability of an assessment instrument begins with reliability studies. There are 2 measurements of reliability that are reported by the test publishers. Those measurements are reliability coefficients and standard error of measurement, SEM. First of all, how and what the test publisher report is very important. Read the rest of this slide to understand the reporting details. It is with this information that educators can evaluate the quality of a test and if that test is appropriate for their schools and students. Next, we will review the basics for reliability coefficients and standard error of measurement, because without a strong understanding of these concepts, you will not be able to judge the quality of a test instrument.
Reliability coefficients? You gotta be kidding me. No, I'm not. Here we go.
Reliability correlation coefficient shows the strength of the relationship between 2 variables in a single population. It ranges from -1 to +1. A coefficient of 0.80 or higher is necessary to be acceptable.
got it. So what about those SEMs? Onward to SEMs!
Administration of an assessment instrument is subject to many errors. Testing environment, examiner errors. Examinee may not exhibit their best performance. Test itself may not elicit the best performance. For example, some people have a terrible time with essay tests and others with objective or timed tests. All errors contribute to lowering the reliability of an assessment instrument. So, we assume there is going to be error and we measure that error. So, a publisher will determine the amount of error associated with individual test scores, test items, item samples, and test times. Publishers then report the amount of error so consumers can decide if that test is good enough to use. When SEM is small, we can be more confident in the quality of that test instrument. The SEM is inversely related to the reliability coefficient, which means as the reliability becomes higher, the SEM becomes lower. The next slides will present examples of SEMs compared to reliability coefficients. Then it will make more sense. Here is an example of one test and the actual reliability coefficients compared to SEMs. Notice that the reliability coefficients are reversely related to the SEMs. This means that as the reliability coefficients increase, the SEMs for that same reliability study will decrease. You see, the reliability coefficient is a higher number. That means it's a good test. At the same time, the SEM will be low. That means it's a good test, a reliable test. See it? When judging a test instrument, we consider the reliability quality as measured by reliability coefficients, or SEM, and the purpose of the testing. There are different reliability criteria for the different test purposes. Read through this slide to learn more about the criteria for judging a test instrument.
Okay, enough on SEMs. What's a CI?
Confidence intervals. The acronym is CI. We never just report one number as the student's score. We always report the student's performance within a range of scores. The SEMs create the confidence intervals, and the confidence intervals determine the range of scores. The range is called the estimated true score. Confidence intervals give us the range of scores that a student would be expected to score if he or she took the test again. In other words, the estimated true score. Confidence intervals continued. For example, if the student's standard score on a reading test was 80 and the SEM creates a CI of plus or minus 5, then the student's reading performance would be reported in the 75 to 85 standard score range.
How do I know if a test is acceptable? And for what purpose? You using this stuff.
To evaluate the quality of a test instrument, educators should examine both reliability coefficients and SEMs. This should be done for all reported groups. The publishers should report both SEMs and reliability coefficients for each grade or age level and for each population. Secondly, educators should look at what the publishers reported for specific groups. Again, examine the SEMs and the reliability coefficients. Finally, look specifically at the age grade levels. The test needs to match your students. Then look at the population characteristics such as ethnicity, SES, ELL, urban or rural. The test population characteristics should match your students. Understanding the desirable standards helps us use reliability study results properly. If we are planning on testing a group, the acceptable reliability should be a minimum of 0.60. If we are planning to test an individual, we must also consider the purpose of the assessment. If it is for placement decisions, the acceptable reliability should be a minimum of 0.90. If it is for screening decisions, the acceptable reliability should be a minimum of 0.80. Finally, we stop to look at the confidence intervals. The best CIs are based on percentile ranks or standard scores, and we need a small CI, not a large one. What do you get when you cross a chicken with a dog? A hen that lays poached eggs! Thanks for listening.